Okay, so today I want to talk about how we find intercepts of a nonlinear function given its graph. So let's remember that the intercepts are the place where the graph crosses the axes. So the x-intercepts are the place where the graph crosses the x-axis. So let's look at those first. So remember that x-intercepts are all the places where the graph crosses the x-axis. So this is the x-axis. We're looking for places where the graph crosses it. So I see this place right here. Now this place, it doesn't actually cross through, but it touches the x-axis, and that's okay too, that counts. And then I see a point here. So there are 3 x-intercepts for this graph, and there can actually be as many x-intercepts as you like. There can be as many as you want, and it's still a function. So let's go ahead and see what these points are. So 1, 2, 3, 4, 5, 6, 7, 8. So this is -8. So the x-intercepts are -8, and then 0 is another x-intercept, and then 1, 2, 3, 4, 5, 6, 7, 8. 8 is another x-intercept. Now, if we're going to ask what are the y-intercepts, if it's a function, there should only be one y-intercept. So as long as it's a function, there should only be one y-intercept. So let's take a look at our y-intercept. So that's the place where the graph crosses the y-axis. So in this case, it crosses right here at 0, 0. So in addition to being an x-intercept, 0 is also a y-intercept. And so the x-intercepts of this function would be -8, 0, 8, and the y-intercept is just 0. And I'm actually going to go ahead and erase this because in a function, you should only have one y-intercept. Otherwise, it's not going to pass the vertical line test.